Welcome as we start our introduction finally into the calculus section. And we're going to start this off with derivatives. So taking a look at the definition here, a derivative is the equation of the slope at any given point. Or the derivative of a function at some point characterizes the rate of change, same thing as slope, of the function at this point. Alright, so more importantly, a derivative is a real big part of calculus. It's the process of finding the derivative is called differentiation. And just with derivatives, the inverse or the opposite operation of differentiation is called integration, or we'll do integrals later on. So right now we're starting with derivatives. There are a few basic things to look at first. Okay, so some technical terms here. So basic derivative rules are as follows here. So we're going to see it as d over dx, so that means derivative. We're also going to see f prime of x, okay, so not inverse, but f prime. We're going to see dy dx, and we're also going to see it as y prime. All of these indicate we're doing a derivative problem. All right, so those are instructions we might see. All right, so these are basic derivative rules. Now, underneath here, I've got the 11 most common rules that we're going to use for derivatives. All right, some of them start off pretty easy, then get a little bit more complicated. And as we run into these rules in the problems, I'll go back and we'll take a look at what some of these mean. But if you want to make a note of it, number 3 right here is the one that's kind of most important to us. This is the one that's going to show up the most. All right, everything over here on the right hand side, these have to do with our trig functions: sine, cosine, cosecant, secant, tangent, and cotangent. And then we have a couple of other basic rules over here. So not necessary to memorize them just yet, but at least have them written down or bookmarked so you can look back at these ones. All right, so let's get this started. All right, so our first example here. So for the next couple of problems, the instructions are going to be find the derivative. Okay, so our first one here. Find the derivative. So I'll call this number 1. All right, they're going to give us f of x equals 9. We want to find the derivative of this. Okay, so I know that the derivative, if I have f of x, my derivative is going to be f prime of x. That indicates it's going to be the derivative answer. Now let's look at what we have here. It is a 9. 9 is a number. It's a constant number. All right, a constant number. So if I look back up here, it's actually going to be rule number 1 right here. If we're taking the derivative of a constant, just a number, see, no x, no variable, if we're taking the derivative of a constant number, it's going to be 0, no matter what. So if I have a function that is 9, the derivative is going to be 0. So for example, the same thing, if I was given f of x is 1234, the derivative of this, it's a constant number, is just going to be 0. Okay, so any constant number, the derivative of that is going to be 0. Let's take a look at something else. Let's say they give us a function, f of x equals x to the 7th. Okay, now this time, I've got a variable with an exponent. Alright, so the derivative of this, so f prime of x equals, so let's see which rule this uses above. So we've got a variable with an exponent. So number 2 just says a variable with no exponent. Rule 3 says x to a number. So what it says to do here, alright, so let's see what the derivative is going to be. It says take that number to the front, so in this case the 7, and then we're going to take that 7 and subtract 1 from it. So I'll write this rule down here. So the rule is take the number, x, and then the number minus 1 up here. So the number is 7. So what happens is this 7 is going to move to the front. So we got 7x, and then the exponent is just going to drop down 1, aka 7 minus 1. So we're going to have 7x to the 6th power is my derivative of this function. All right, so let's try some more of those ones. Let's say my function is x to the 4 plus x to the 3rd plus x. I want to find the derivative. So the derivative of this function. So let's see. This time we've got a couple terms here, but we're going to take the derivative of each individual part. So x to the 4th, that 4 is going to move to the front, and the exponent drops down 1. So now the exponent is 3. So we got 4x to the 3rd. We move to the next term, plus 3 moves to the front. So 3x, and now the exponent drops down by 1. It's going to be 2. Plus, we can use that same rule here. The exponent we have is a 1. 1 moves to the front. And then the exponent drops down 1. So 1 minus 1 is 0. But anything to the 0 power is just a 1. So 1 times 1 gives me 1 here at the end. And then we have the rest of it. And actually, if we look back up to the front, or up to the top to the rules, if we have an x all by itself, the derivative is going to come out to 1. So that's why we got 1 for that last piece. All right, so here is the derivative with multiple terms. Let's get a little bit more complicated. We're going to find the derivative again. So we've got f of x equals x to the 7th minus 6x to the 5th plus 3x squared minus 1. This time 4 pieces. So let's find the derivative of this. So f prime of x. All right, so these exponents move forward and then the exponents drop down 1. So 7x to the 6th. Where it gets a little bit interesting here is this 5 is going to move down, but you see there's already a number there? Those numbers are going to get multiplied to each other. So 5 times 6, and then x to the, drops down by 1, 4. Same thing here, this 2 is going to move forward. So we plus 2 times the 3 and the x. And the exponent drops down 1, so x to the 1. Minus, a constant number. If we take the derivative of a constant, it comes out to just a 0. So we can go ahead and clean this up in the next line. The cleaned up derivative, first term is 7x to the 6th. Next term, minus 30x to the 4th, plus 2 times 3 is 6, and it's just an x, and then minus 1 we don't need to write anymore. So there's the derivative. Okay. Now let's get into the trig functions a little bit. If they give us a function cosine x minus sine x, all right, 2 pieces. I want to find the derivative of this and the derivative of this. So let's take a look back up there. All right, we're going to find f prime of x. We're going to find the derivative. So the derivative of cosine. All right, so let's find cosine. So right here, the derivative of cosine is negative sine. So let's write that. The derivative of cosine is negative sine x. Minus from the minus sign there. And now let's find the derivative of sine. Back up here, the derivative of sine is positive cosine. So a positive cosine, but it still has the negative from the equation. All right, all the negatives work out. Everything is fine here. That's your derivative. I wrote example. What number was that? That was 5. Just right there. Okay. A sixth example. Let's find the derivative of this function. We've got 5 cotangent theta minus cosine theta. So maybe something to look at this time. It's got cosine, or it's got theta instead of x. So actually it should be theta over here. But that's still the variable. It doesn't really matter what's happening with that. It's just like x, just theta in this case. So let's find the different pieces of this. Now in this case, there's a 5 already in the front. Anything in the front just kind of gets left alone. Okay, that doesn't change at all. So 5 is going to get moved down. So we've got f prime, or the derivative of theta. That 5 is going to get moved down. Let's find the derivative of cotangent. Okay, derivative of cotangent. Scrolling way back up here. Derivative of cotangent is negative cosecant squared. And we're using theta instead of x. So negative cosecant squared theta minus, because that minus sign gets brought down. And we already did that one. The derivative of cosine is the same as negative sine x. So it looks like a little bit of cleaning up to do here. We have negative 5 cosecant squared theta, and I apologize, this is supposed to be theta. Negative negative comes out positive sine theta. All right, so the derivative of this equation is right here. All right. Now let's get a little bit trickier. So, new type of example. Now, when they say find the derivative, okay, they're talking about, they can also say it, find it dy dx, okay. Now, what if they ask you to say find d3y dx3? So notice the difference here of 3. So whatever that number is, that's how many derivatives they're telling you to find there. So this is telling you to find the third derivative. So do it once, do it twice. All right. So what they're going to give us. Let's say they tell us that the derivative of a function is 12x cubed minus 6x plus 2. They want us to find the third derivative. What we're given right here is the first derivative. All right? So what we're going to find next is the second derivative. All right? So these 2 marks here mean we're finding the second derivative right now, and eventually we're going to find the third. So all it is just keep taking the derivatives until you get to the one that you want, in this case the third. All right, so let's do this. Exponent comes down, drops down, so 3 times the 12, x to the power of, now it drops down to a 2. This one has an exponent 1. That's going to drop down, or negative 1 times 6. X to the, drops down by 1, 0. Plus, if we take the derivative of a constant, that's going to come out to just a 0. So let's see, the second derivative of this function, 3 times 12 is 36, x squared, minus 1 times 6 is 6, x to the 0 just becomes a 1, and then the 0 is gone. So you'll notice terms disappear as we continue to do these derivatives. Now they want us to find the third derivative. We have the second, so let's just do it one more time. We're going to find the third derivative. All right, we want to find the third. I'll change the color on that. We want to find the third derivative. So let's just do this again. The exponent 2 is going to come forward. So 2 times 36, keep that x, and now it's x2 becomes x1. And then anything that is a constant If we differentiate it, it becomes 0. So in the end, the third derivative, f third, 2 times 36 is a 72, x to the 1 minus 0, third derivative. All right. And one last example on here kind of shows us to evaluate. It's going to say find f prime of 2. Okay? So these are the instructions. Find f prime of 2. The actual equation is f of x equals 3x to the 4th, not plus, minus 3x squared plus 2x plus 5. All right, so let's interpret this. This right here is the original function. This is telling us to find, that prime means find the derivative. But now there's a 2 right here. So it says find the derivative and then plug in 2. So first we need to find the derivative, and then we're going to evaluate it at 2. So find the derivative and then plug in 2. All right, so let's find the derivative of this. So f prime of x, the derivative is, all right, so hopefully we're getting good at this. 4 gets pulled down, and we're going to do the math in our heads here. So 4 times 3 is 12, x to the 1 lower, so 3, minus 2 is going to get brought down. 2 times 3 is 6, x to the 1 lower, so it's just a 1. And then remember, if it's a number and then an x to the 1 power, that x is going to disappear, so it's plus 2. And then 5, the derivative of 5 is just a 0, so we don't need to write that. So that's the derivative. If it just told you find the derivative, that's it. But we want us to find the derivative at 2. So f prime of 2. So instead of x, we're going to plug in 2 everywhere. And I'll just draw those blanks for us first. Minus 6. Okay. So everywhere we had a blank, we're going to put a 2 in there. So let's solve it out. So 12 times 2 squared, 2 cubed is 8. We still have the 6 and the 2, plus 2. 8 times 12, that gives me a 96, minus 12, plus 2. 96 minus 12, that's an 84. And 84 plus 2, 86. So not only did we find the derivative, we found out what the derivative is at 2. So if you plug in 2 into the derivative, we get 86. So a lot of different rules kind of thrown at you today. Just understanding the process. Once you get it, it's bring that exponent down and then knock it down by 1. All right.